Hey YouTube, as promised today the video of the installation of the battery pack and the Sunny Island. So what you can see here is the encasing. It's already connected. Later on in the movie you'll see how we actually installed the battery. And yeah, it's not that sunny as yesterday, so it's charging somewhere around 20 amps as you can see. And I want to run you through a little bit of the setup before we show you the battery installation. So at the bottom where we have the monitoring, there's a coil that actually measures the amount of amps going in and out, which gives you an instant view on what the battery system is doing. Reason for it is that I can only communicate with the rec-bms over Bluetooth, which requires its own power supply. And as you can see here, we bought a module that is connected to the mains instead of the battery, to feed the Bluetooth module and some other bits and pieces like the real-time monitoring at the bottom, which was mounted in the door. This is the rec-bms. I had a few questions how it's connected. Well, on top there are two connectors, one CAN bus and one RS485, and the CAN bus actually communicates with the Sunny Island. So it explains them, hey, what's the state of charge, what's the battery health, how is it balanced, etc, etc. And it's allowing the Sunny Island to throttle back the charging when it's almost full. Pre-charge controller connected to the relay, which allows a small current to pre-charge the Sunny Island instead of a cold connect to the battery, which creates a lot of rushing currents you don't want. Damages the electronics and limits the lifespan. Main circuit breaker, 100 amps per Sunny Island. And what you also saw previously on the board was the overarching fuse for the entire system, 300 amps. Solar converter, main switchboards towards the house, installed by Nibe Techniek. Great guy, Nick Bucker, does a fantastic job for us, especially with the wiring and stuff. That's not our forte. So how did we actually install the humongous battery? As you can see here, it's long, it's heavy, and not easy to maneuver. So we put it on two dollies to allow it to move around. In total there are somewhere around, exactly 85 modules, 48 volts. So creating an 11 kilowatt battery pack, theoretical. And when we actually measured it yesterday, we noticed that the residual load in the batteries and the total consumed, taking all that into account, they were getting somewhere around 10 kilowatts from a single battery pack. That's actually quite well, but at least better as expected. When we do the math and we calculate it back, it's somewhere around 2.4 amp hours per cell, which is lower than I hoped for, because we bought the 2.6 to 2.8 batteries from the Groter Electronics Recycling. But that probably has to do with the residual load in the battery, which is a little higher than normal. I think it stops around 3.45 volts, leaving 10% charge in the battery. And the upper limit of which the rec-bms is configured to is 4.15 volts, so not 4.2, to increase the lifespan. There are some debates if you need to actually go to 4.1 volts. I don't know what to think about it. We will have to see. This is the first module being installed. We will monitor it for an hour. We will monitor it for a year, and then see what happens. And in the meantime, I'm going to do some expansions on the rec-bms to make it network aware, because currently I'm not satisfied with the mechanism of reading the data out of the system. As you can see on the bottom, battery is installed. We're now doing the balancing lead and making sure all the voltages pan out, that the plus and minus is not reversed, because that would fry the BMS for sure. And as you can also see, currently the meters on the copper bar, because it's not connected yet. So creating a new 50 square millimeter lead to connect towards the battery module.
Brilliant.
And we're now at the point of actually connecting the module towards the copper strips. So it goes from 50 quadrat millimeter onto copper strips, 30 millimeter wide, 5 millimeter thick. So it's 150 solid copper. That allows us to connect basically all the 4 to 5 battery packs that we are planning to build, and also allows us to connect the 2 additional sunny islands to create a 3-phase system instead of the single phase that we have today. So once installed, we actually were very curious how it worked, if it worked. And yesterday we had an extremely beautiful day, no clouds in the sky whatsoever, so that was a good time to measure the actual storage capabilities. And as you can see, there are a few things that are problematic because we are discharging, no, I need to say it right, we're charging the batteries, and in parallel we're also feeding back into the grid. That's the blue part of the graph, and that's of course very annoying because you want to store all capacity in your batteries. So that means that our battery system today, the 10 kilowatts that we have, for a 100% ideal sunny day is not sufficient, meaning we need to add an additional battery, which we will do, and it allows me to also show you a few more things I learned along the way to prevent catastrophic failure when you're actually interconnecting, but that's something for a new video. Alright, thank you guys. I will address all the questions and remarks made on Facebook or on YouTube as much as I can. If you have some very detailed questions, then please send a private message, and yeah, until next time.